for this type of question, the course and the prerequisite, there's a very typical algorithm to solve it. It's called topological sort. And the most popular way of solving topological sort is using the Kahn's algorithm, K-A-H-N. Basically, Kahn's algorithm, it keeps track of an in degree and an out degree. In degree is like, for example, for this one, 0 would be the prerequisite of 1. So 0's in degree would be 0 because you don't need to take anything to take course 0. And the 1 in degree would be 1 because you need 0 to take 1, and the out degree of 0 would be 1 because it's pointing to 1, but the out degree of 1 points to nothing. I guess it's a little bit hard to explain because if it's like in graph form, it will be easier to explain. But it will be clearer when I code the things out. So let's start coding. I'm gonna use from collections import default dictionary. I'm gonna use a default dictionary to keep track of my out degrees, and I'm gonna use like it as an adjacency list. And degree will all be defaulted at 0 in the beginning, and then it will be to the number of num courses. And let's expand our let's append our adjacency list using the data we have in prerequisites. So for A, B, and prerequisites, basically B is the prerequisite of A. So for adjacency list, it's basically like our out degree list. It'll be adjacency list of B will append A because you need B first to take A. And then here we also increase our in degree. The in degree of A will be increased by 1 because to take A you need B first. So we have in the graph the B will be pointing to A, so you need to take B first before A. And since it has an ingoing edge to A, you increase the in degree by 1 here. And after appending data into our prerequisites, we need to create our queue. So our queue will be defaulted with all the nodes that have initialized with all nodes that has a degree of 0. So I'll do that by doing this I for I in range of num courses. We want to go through all the courses, and then if in degree I equals to 0, then we'll append it to our queue. So it's initialized with all nodes that has in degree of 0. And since we need to output the results, like the order of the courses that we take, we can have an empty list to store our result, and then we can start writing this. This is basically kind of like a BFS way to write it. So while Q will pop off the first node that has in degree of 0. So course equals Q dot pop 0, and then and then after we pop this, we wanna decrease the indegree of the ones that are dependent on this course. So I think for next course, an adjacency list, of course, the indegree of next course minus equals to 1, and then if indegree of next course equals 0 now, it has no like we already basically marked the first course as taken, and then when we visit the next course, basically if it has an indegree of 1 before and now it's decreased to 0, we'll treat it as we want to append that to our queue. And in the end, I want to check if, so for topological sort, it has to be on directed graphs with no cycles. Because when there is a cycle, there won't be a solution. That means when there's a cycle, it means it just always like, so for example, A, B, C all point to each other, then there's no nodes with indegree of 0. That means there's nowhere for us to start on the topological sort. It wouldn't even enter this queue because it wouldn't fulfill this line. And so basically at the end we check if there are results, because if there's no results, if it's impossible to finish all courses, we just return an empty array. So we can check by doing if, I forgot to append our results, so result.append course, and then here if length of result does not equal num courses, then we know that it's impossible to finish all courses. We just return an empty array, and then otherwise we return the result. Yeah, so this is how I would solve this question using topological sort, Kahn's algorithm. Please let me know if you have any questions, and thank you so much for watching.